In P4, we're going to really focus on lines. So one of the things that you really need to know about lines is slope. As you can see, Brinks made an emphasis of needing to know it for the entire year. Slope is huge. It's something we're going to kind of relate it to. And then slope, or ROC, or rate of change, is just a thing that has a lot of application. How are things changing on a business model? In psychological studies, we actually analyze rate of change with data and education. So slope is just a huge thing there. You've studied it since middle school, but here you go. Slope, usually represented by the letter M. Change in y over change in x. The delta symbol, or the triangle there, means change. And then you may remember this formula: y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Good old slope formula, second point minus first point. So we're just going to go ahead and find the slope. I'll show you the slope formula for 1, and then I think the change definition is a little bit easier. Some of you might also remember rise over run for a definition of slope, but that is more for a graph. So if I'm going to do the actual definition of slope through the slope formula, we could say this is 0.1, this is 0.2, so we've got x1, y1, x2, y2. So I could just plug in the things where they go in the formula. So y2 is -3 minus y1, so minus -3 all over 4 minus 2. Subtracting a negative means a plus, so we've got -3 plus 3, that's 0. 4 minus 2 is 2. 0 divided by 2 we know to be, or 0 divided by 2 is 0. So with this here, we see a slope of 0. This is typical of all horizontal lines. So if you think about horizontal, horizon is built right into the word. And if you think about the sun on the horizon line, you can kind of see there's a 0 there. Just a way to remember it. But I think the slope formula oftentimes can actually be more work than what you need. I think about it from the change in x, change in y perspective. So when I think about it, I go, what happened with my change in y's? From 5 to 3, what happened? Well, I went down 2, so -2. But from 3 to 5 with the x's, I went up 2, +2. That lets me know my slope is -1. When we get a number for slope, it's always going to be a diagonal line. So same thing here with the y's, down 4. And the x's, I actually go up 8, 2 to get myself to 0, and then 6 more to get up to 6. So my change in y, my -4, comes over my change in x, which is 8. So I'm going to get -1/2. Then I go over to D. The change here, 4 to -3 is -7. From 2 to 2, no change, 0. Change in y divided by the change in x. When I divide by 0, we have to remember that that is something in math called undefined. That means I do have an undefined slope. That is something you are going to want to write. If you ever get a divide by 0 for a slope, make sure to tell me it's undefined. I want to make sure you understand what that means. But undefined slopes are always characteristic of vertical lines. Just as horizontal lines are always a slope of 0, vertical lines are always going to match with undefined for slope. Here you can see a summary of different styles of lines, their general equations, and then how you might put some stuff in the calculator. So again, we're going to deal a lot with the calculator in this class, learn how to use it. We'll use these as much as we need, but slope-intercept is the one people remember the most. Point-slope form is actually probably the nicest one to work with, even though it seems like a complicated formula. So we're going to go through the next problem and actually use both of those. So we're going to find 2 points, and then we're going to actually find the equation of the line. So if I'm going with point slope form, I know that that means I need to be filling in this template. I need to figure out my number for y1, for m, and x1. So we've got x1, y1, x2, y2. Now you actually here could use x2 and y2. It doesn't matter. It just needs a point and a slope to be filled in. The name of the type of equation is really helpful to let you know what you got to find. So as I go to fill this in, y1 I see, if I'm going to pick this point, I've got 1, so minus 1. We'll find m in a second, but x1 here is a negative 3, so x minus negative 3 turns it to a plus 3. And then the slope, I'm just going to calculate it down here. Again, I'm going to use the change idea. So from 1 to 6, I went up 5. From 3 or negative 3 to positive 3, I went up 6. Change in x is 6. So my slope is 5/6. Now again, I said you could use the other point. The slope did not change. But if I want to plug in this point instead, y minus the y value of 6, and then over here, x minus the x value of 3. Either one of those would be considered our correct answer. That didn't take a lot of work. The slope-intercept way, actually, even though you might be more familiar with mx plus b, takes a little bit more work to set up. So in slope-intercept, you need a slope, you need the y-intercept. Well, we already found the slope from the other problem, so we're going to reuse it, 5/6. But the intercept is the letter b, and I'm going to have to solve for it. So if I think about y equals mx plus b, I know m to be 5/6. X and y, you get to pick a point, because this is an x, this is a y, and then you can solve for b. So I'm going to pick this one right here, because it has positives in it, and I think positives are easier to work with. So the y value there is 6, the x value is 3. So then 6 will equal, after multiplying these, 15 over 6 plus b. You could think about it as 3 over 1 there. Then in order to solve for b, I've got to move it over, but it might actually be helpful to maybe make a decimal out of this. This is actually 2.5. And then subtracting it over, I could see that 3.5 equals b, or 3.5 as a fraction, or if you worked with fractions to solve it, you would get it to be 7 over 2. So now that I have both pieces of information that I needed, I can write the equation of my line as y equals 5/6 x plus 7 over 2, or 5/6 x plus 3.5. So we're going to actually put this in the calculator, but I can't put this in the calculator yet. It's not solved for y. So what you're going to have to do to put that in the calculator is bump one of them over. So we're going to put y equals 5/6 times x plus 3 plus 1 from that side into y1. And in y2, our second equation, we'll put this in, 5 over 6x plus 7 over 2. So we'll go to the graphing calculator here. So I'll hit y equals, clear out anything that might be in there. y1, anytime I do a fraction, parentheses are helpful. 5 divided by 6. Then type it in exactly like how you see it. Parentheses, x plus 3 plus 1 Moving over to y2, again, putting in a fraction, so I want 5 over 6 in parentheses, x plus, again, parentheses around 7 divided by 2. Also, my recommendation is, unless you have a reason otherwise, always hit zoom 6 to get the standard graphing window. So what do we notice here? We put in 2 equations, but I don't see 2 lines. Since this is the same set of 2 points, whatever version we put the equation in, it should represent the same line. So that's why we're only getting 1 line. We'll also be able to put this into the calculator, but again, the problem is we don't have it solved for y. So we would have to bump that 4x over and then divide by -3. But what's important when you divide is that you hit everything. So -4 over -3 becomes a positive 4/3. 12 divided by -3, -4. So again, we could just type it in here, clear it out. With fractions, you need parentheses. Make sure you know that. But this line makes sense. Make sure to think that when you graph something, it makes sense for the equation you were given. Positive slope means it should go up and to the right. And here's a negative y-intercept right there. Looks like the pieces are making sense. Going to the back side, we've got to think about what happens if lines are parallel versus perpendicular. So parallel lines look like this. They go in the same direction. Now, if slope measures the slantiness of a line, and slope measures kind of the direction, if these are going in the same direction, that means parallel lines must have the same slopes. Perpendicular lines, on the other hand, have a right angle between them, and that means that their slopes have to be opposite reciprocals of each other. They're going to kind of be the exact opposite of each other. That instead of being positive, they'll be negative. We'll talk about some flipping. So we're going to find these equations. We're going to compare it to this line, and we got to put it through the point 2, -1. So if I want a parallel line, I know the slope has to be the same as this. So let's put it in mx plus b form so that I can just pinpoint the slope from there. So I will bump the -3x over by subtracting 3x from both sides. I bump it over. Then again, I will divide everything by 4. So I get y equals -3 over 4x plus 2 now. So this is the slope. So that means the slope of the parallel line, I'm just drawing little parallel lines just so we kind of can symbolize that this is the parallel slope, has to be the exact same. It also has to be -3/4. This just said find a line. So when I want to write the equation, we don't care what form it's in. I'm not going to care what form you write. As long as you give me one that makes sense, that's what counts. So I might actually want to use point slope form. Now, why would I want point slope form? Well, I'm given a point that it needs to be on, and I know its slope. So because I know a slope and a point, as the name says, point slope form is really helpful. Because once I plug in the y value of -1, turns that positive, I put the slope in, then I put in the x value. This is it. You don't have to do anything more. This is a perfect equation for a line. That's why it's simple. That's why it's something that I would recommend point slope form. Perpendicular, though, we got to talk about what opposite reciprocal means. So if I'm thinking about the original line, The original had a slope of -3/4. So then the perpendicular line, it needs to have an opposite reciprocal. So opposite is going to mean change the sign. Reciprocal as a word means flip it or flip the fraction. So that means, here's the symbol for perpendicular. So the slope of something that's perpendicular is going to have it's not going to be negative anymore, it's going to be positive. And instead of 3/4, I've got to flip it to be 4/3. So then I'm going to fill in the point slope form again. So it'll actually look really similar to this because the point part is the same. We're asked to still put it through this point. So the y plus 1 and the x minus 2 are going to be the same. The only thing that'll be different is this is now the number for slope that would make it perpendicular. You would be able to see the parallelness and the perpendicularness if you were to put it on your graphing calculator. Maybe you want to put it on Desmos, but this is the algebra that you'll need to do that. Last example. So we want to find the equation of the line through these points. There's context around this in the book. We'll skip that for now. I just want to make sure we know how to get the equation of a line between 2 points. So with this here, something like this, you could do the change idea. You could also do the slope formula way. So with the change way from 7.4 to 9.2, I'm actually adding 1.8. So I've got 5. Now, we don't usually keep decimals with fractions, so you could just use a calculator to figure out that this is 0.36. So now we need to just write an equation. I've got a slope. I'm given some points. Again, point slope form going to be really helpful. I could pick this point or this point. It does not matter. So I could have y minus 7.4 equals this 0.36 times x minus 1998, or y minus 9.2 if I'm going to use the other point equals 0.36 times x minus 2003. Either of these would be acceptable. So we're seeing now, will this be the same equation if you use either point? The answer is no. Just kidding. It's actually yes, if we're talking about these two equations. They represent the same spot. This is related to what's in the book. Never mind, we'll skip that. But your homework for this section is 1 through 25 odd and 43 to 46. Please let me know if you got any questions, but there are your P4 notes.